Hey guys, what's up? It's your boy Trix. Today we're going to be doing another Rust video. Gonna see how far we can get today. It's probably going to be another 3. But yeah, let's get started. Today we're going to be doing Armstrong numbers, then which one? Armstrong numbers, not allergies. Armstrong numbers, acronym, and then yeah, Armstrong, acronym, then allergies. I feel like that's the best way to do it. But yeah, we'll do these 3. I don't think I have any more easy ones to do. Yep, no more easy ones. So we're gonna do Armstrong numbers, acronym, then allergies. So let's get started. Whoops, forgot that you guys couldn't see anything. Oh, okay, there we are. Alright, you guys can see everything now. Okay, Armstrong numbers. Armstrong number is a number that is a sum of its own digits, each raised to the power of the number of the digits. Okay, so let's do control P. Solutions. This one and this one. Okay, so this one looks most interesting. So, looking at this, all this is doing is creating a element named digits and a variable named digits which takes sum. Okay, so let me explain this side first. It's always best to explain this side first. Okay, so firstly it takes num and typecasts it as a 64-bit float, right? And then it gets the logarithm of this num, of this floating point number in base 10. So if you've ever done mathematics at university or in sixth form, you will know that when you do logs, it basically does, hang on. So log, so a log basically gives you the reverse of a exponent. So for example, so in this example, it has 9 to the power of 1 equals 9. So log of 9 with 9, log 9 is just 1. Same thing. If you have log 2, and let me just replace the log 2 to the power 7, right? That would be 128. So log 2 with 128 would give you 7. So 2 to the power 8 would be 256. So log 256 would give you 8. So it just gives you the exponent that you would, it would give you the power that you raise the number to retrieve a given answer. So this is the base, this is the answer, gives you power. That's all a log does. So all we're doing in this example is we're getting base 10 of this number, and then we're adding 1 as a float, and then we want to get the smallest number this will be. Say for example we get 1.5, floor would make sure that it gets the smallest that number could be. So 1.5 floored would give you as a float, I believe it will round down to 1. So all floating point numbers would round down if you use floor. If you use ceiling, it would round up. And after it's done all of this, it would typecast this as an unsigned 32-bit integer. Then all you're doing is, and then it would assign this whole value to the variable digits. And this digits variable is immutable, so you can't change it later. Then we iterate from 0 to the value of this digit variable that we calculated here using the spread operator from JavaScript. And then we map each integer from this iteration. So we extract the integer using this, and then inside of this map operation we get the original number, we divide it by 10u32. I'm assuming that this is just a 10-bit unsigned 32-bit integer. This is just 10 as a u unsigned 32-bit integer, where we raise it to the power of the iteration, and then we modulus that variable by 10. So you first do the division, then you do the modulus. Then all you do is raise it to the power of whatever this digit is. Then, once it's done this for each iteration of this loop, it summates this variable. Sorry, it summates this map as an unsigned 32-bit integer and checks if it's equal to the number. Because all this is checking is if you add the hang on, a number that is the sum of its digits, each raised to the power of the number of digits. Okay, so for this example, 9 to the power of 1 is just 9. 10 would have 1 squared plus 0 squared, because they're 2 digits. This would have 1 to the power of 3 plus 5 to the power of 3 plus 3 to the power of 3, which equals 153. 154 isn't, because it would have 1 to the power of 3, 5 to the power of 3, 4 to the power of 3, which is over 154. So all that's doing is mapping each digit, squaring them, and then... Wait, no, it's not squaring them. It's raising them to the power of the number of digits there are in this number. So this just retrieves the number of digits in this number, right? Then it's just iterating through each one. Then is retrieving the digit of the number, raising it to the power of the number of digits in the number, and then summating this expression to check if it's equal to the number. If it's true, then it's an Armstrong number. If it's false, then it's not an Armstrong number. Ha! That took a while for me to understand. Complete, confirm, show me more. Next we have acronym. Okay. Convert a phrase to its acronym. Techies love their TLA, 3-letter acronyms. Help generate some jargon by writing a program that converts a long name like portable network graphics to its acronym PNG. I have no clue. Solutions. Okay, let's take a look. If I can explain it, then I'll submit it. If I can't explain it, then I won't submit it. Okay, so you're taking the phrase, then you're applying these stream operations. First, you're splitting the phrase by each character in the phrase. So you're extracting each character using this. And then you're checking if the character is a white space, or the character is an underscore or a dash. Because basically what you want to do is you want to split the characters on each space, dash, or underscore, because you don't want to include them in the acronym. Okay, first line done. Then you have this map. All this is doing is extracting the word from each okay, so it's split you have the original phrase, right? This splits the phrase into separate words where you split on each white space, underscore, or dash. You would also include like commas, apostrophes, and stuff like that. No, you would only include commas as well, because commas are the only ones that aren't like... Yeah, you'd also include commas, but I'm assuming ASCII whitespace also includes commas. And then all you're doing is in here, so this would split each word, right? So it would just split the whole phrase into each word and remove all of the spaces and underscores and dashes. Then this one gets those words, converts them to a character array. This converts to a character array. Then gets the first index of the word, so first character of the word array. I mean first character in that characters array Then it chains it, so it repeats this for each word. And then word.chars, so it just gets the character array of that word again. And then skips the character if it's an uppercase character, and filters the characters for all uppercase characters. So it will just get the first character of each word in the original string array that this creates, and then converts that word into a character array, gets the first character of that word, and makes it an uppercase character. Then all it does is it collects because this will just return the first index of the characters. First character of the words in each word. This one collects the characters into one long string. So the first character of each word into one long string, instead of making multiple small character arrays of the first character of each word. And then this just makes it uppercase. So this just ensures that all of it is uppercase. This just retrieves the uppercase too, because if it's already uppercase, you want to retrieve that anyway. So skip while C is ASCII uppercase, dot filter C is uppercase. Honestly, I'm not sure about these ones now. I know it retrieves, because this retrieves the first character in the word. I'm not sure about these though. This just converts whatever the first character you retrieve from this to an uppercase letter. Markers complete, confirm, show me more. Okay, and then we have, that was acronym. Now we have allergies, continue. Okay, this is going to be a bit, let me reset this to, cool, it's reset. So we have pub strat allergies, and this is supposed to instructions. Okay, so it's supposed to have a score. So I'm assuming the first thing in that score, colon U32, like that. And then this will just return score. Wait, no. Allergies, bracket, score, colon, score. Right, and let me just run that. Okay, then we have is allergic to, determine if the patient is allergic to allergen. So you just the allergen and then that, and then return the list of allergens contained within the score with the allergy struct was made. Could I assign variables to these? Because this is supposed to be, okay, let me just see. 1, 2, 4, 8, 16, 32, 54, and 28. Okay, so allergen. Okay, so I want to see how someone does this. Solutions. This one. Okay, so yeah, U32. I just assign that as scores, but that's fine. This one. Okay, wait. Const allergens. This is making a lot of new stuff for no reason. U8 pub new X self allergens XIS use. U8 and U32 shouldn't matter. OU8.8 map X unsafe SUD mem sub transmutate X allergic to filter X allergic to. If I grab this, I just want to see, because this should still work, even though it's not the same. It should work if I just change this to a U32. And then in here, if this works, I'm going to explain why I've done this. I might need to change that to a 32 actually. Where? Is it this one? No. What? Students not the proper organic program. Planning Allergies. 107979. Oh, whoops. Forgot that I copied that. Okay. Let me copy this and then Control C. Control Shift that. 32. This one. This should work. I might need to change it to, you know what, I'm gonna change it to 32. 32 as well. Um, 29. Oh, hang on. Aha, I put them in the wrong place. Allergen is a bit. What does it do? Okay, let's try U8. Cannot move out of widget behind shared reference scale as you move occurs because allergen has type allergen which does not implement copy trait. Mm-hmm. 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 Hmm. I don't know. Let me see the first one. Okay, so use of allergen. Okay. Eggs, this is your binary shifts. Basically, this just says that, oh, this is 1, this is 2, this is 4, 8, 16, 32, 64, 128. So just actually writing it. Allergens 8. This is just saying that there's 8 elements in allergens. This is saying that U32 is allergens N, they're allergens as U32. That's fine. Self allergens and allergens equals allergen. So this is where it does the iteration. Interfilter a self is allergic to, passes it, clones, collect. Okay, this looks like an elegant solution, but I'm pretty sure you could just put 1, 2, 4, 8, 16, 32, 64, 128. So let me edit that actually, because I can try to improve on this. So in here was basic. Okay, let me paste. This can just be 1, 2, 4, 8, 16, 32, 64, 128. That's all that those equal to, because it's defined in here what they are. Then you have a const for allergies, which is just something that you can iterate over, just defining each of the elements inside allergies. So allergies, that's fine. Then you have score U32, that's fine. Then allergens. It's because you define the struct as allergens. Oh, okay, that's fine. Same thing. Then you have this in here. Wait, is that the allergies function? No, this is the allergic to function. That allergen star allergen as U32, then self dot score and allergen equals allergen. This is just checking if the current score and the allergen. So this is doing. It's not doing a. It's not checking if both are present. It's checking if. It's checking the actual like bits to see what the bits are in each. So when you do the AND operation in bits, it checks the number of them that are on and the number of them that are off. If both have 1 in both places, it will say that it's on. So all that's doing is, say for example, in this allergen, it's saying it's AND allergen, right? But all that it would probably have is a number. So if that number is like 256 or something, like way above this, all it's supposed to do is it's supposed to discount all the ones above, all the bits that are above it, and just include the bits that are already on. So 256 will still be cut. Same with 512 and 1024, it will still be cut. 257 will just check all the on bits. It will see that 1 is on. It will discard everything above the 128 bits and just see that, oh, eggs is highlighted. And this will just check if this is equal to the current allergen that's been passed. I think. Why are they using allergen twice? It's booky because they've used allergen 3 times. 1, 2, 3. One of these, this allergen refers to this. This is here. I don't know about this. Oh, it's checking if the score that you've passed is equal to the allergen, because you provide a score already. So if there's like because you were using this to check the allergen, right? So you pass all of the allergens from this into here and check if it's relevant to one of these scores. If it isn't, you return true. If it isn't, if it's related, you return true. If it isn't, you return false. Okay. Then you have this, which just iterates through. Okay, so hang on, let me copy this. So all this doing is iterating through each of these allergens and then retrieving the allergen and passing it to this function to check if the score that was initialized here matches any of the allergens here. If it does, then it will return true, otherwise it will return false. It collects them as a vector object with each allergen to tell you what that person is allergic to. This should work. Why? Cannot find field eggs in the scope. Is it because he used this? No. As you ate? Score. Oh my god, I'm so bloody dumb. Okay. Trait-bound allergen clone is not satisfied. Why? Copy. Oh. He has partial EQ, copy, clone. There we go. These are just like predefined things that you can allow for a specific element. So this is saying that you want to be able to copy and clone this enum, whereas in normal Rust, you wouldn't be able to just copy or clone an enum. You just have to use that enum in place. If you copy or clone it, you're making another instance in memory where you can utilize it, which isn't supposed to, like, I'm assuming in Rust you're not supposed to actually do that, but we're using it here just so that you don't have to redefine all of the allergies here when you're cloning it. But okay. I didn't do a good explanation of that last one, did I? Hang on. Let me try explaining that last one properly. I don't know where allergies has gone. See all Rust exercises. Where's allergies? Allergies, new iterations. Okay, so this is just letting us use all of the functions in allergen. Let us use allergen and all of the things that are defined in allergen by importing it as a library. Then we're defining the struct for allergies as having a variable of score with an unsigned 32-bit integer. Then we're defining all of the things that we could do with the current enum that we defined. So we want to be able to debug this enum. These two I'm not sure, but then we're saying we're going to copy this enum and clone this enum in memory. Then we're defining the enum with the specific values for each allergy score that it would have. Then you're creating a allergens array, which contains each allergen here, and all it does is just have each one defined. That's all. And you're saying that there's 8 because there's 8 different allergens. Then you're defining the implementation for the allergies struct, where you're defining each of the functions for it. So the new function just creates a new allergies with the score that you provide. Then you have the isAllergic to function, which assigns this allergen here, to this variable as an unsigned 32-bit integer. Then all you're doing is comparing the score and the allergen as on their bits, and then checking if it's equal to the original allergen. So this will just say, like, say for example you have 257, like I was saying before, as the allergen, and you have your score as let's say you have the score as like 257 and the allergen is all of the allergens in this. You would just check the bits that are on for both of them to see which of these allergens satisfy this score. So you would see that most of these don't satisfy 257 except for eggs, because when you have 257 bits, let me see, bits 257. 257 bits to bits. I want to see the actual bit notation. Binary notation 257. I just want to see the number. there we are. So this is 257 in binary, right? All this is showing is you'll have 1 on and then 1 on here. Because 1 is on here, it would recognize that, oh, you're allergic to eggs. If it was 256, which is still higher than the ones that we've accounted for, you'll see everything's off, right? But that would just mean that, oh, it's cats. Because when you have 128, it shows everything's off too. That's all. So that's how you match it up. So like when you have 64, same thing. It's just that, oh, if you have so this just shows 64, but because we have 8 bits, 64 only occupies 7 bits currently. 1, 2, 3, 4, 5, 6, 7. Yeah, 64 only occupies 7 bits. So you'll have 1 extra bit on the end that's invisible, that's currently 0. So that's how you know that, oh, the difference between cats and pollen. And then the same thing as you're going down. And then, as I was saying before, this just iterates through each allergen in this allergens list, filters, and then it does a filter operation where you're extracting each allergen and then passing it to this to match if it's related to the score, right? To check if the bits are on in that, and it will return true or false for each allergen. And if it's true or false for each allergen, if it's true, it will store that allergen. If it's false, it will discard it, and it will clone it into its own vector array of allergens and collect it to be returned, if that makes sense. But yeah, we've done acronym. I think we've done 3. We done acronym. Which ones did we do? We did Armstrong numbers, acronym, and allergies. Yeah. So that's it for the rest video today. I hope you enjoyed the video. If you liked the video, please leave a like on the video. If you dislike the video, comment down below ways that I can improve the content on the channel and to make your viewing experience better. If you have any advice on how I can improve my learning of Rust and how I can make the content for you guys to learn Rust better, please comment down below. I have a bunch of links in the description to ways that you can support the channel and support me. Other than that, please subscribe to the channel and enjoy the rest of your day. Peace.